Okay, so on the same notes from last night, you're going to write an arithmetic series is the indicated sum of an arithmetic sequence. The indicated sum of an arithmetic sequence. Now, underneath that, I want you guys to write a little note to yourself. The note is that we only deal with finite arithmetic series. What do I mean by finite? It ends. Yeah, there's a set amount of terms in there. It doesn't go on for infinity. The reason we only deal with finite is because if you have an infinite arithmetic series, like it adds 5 forever, then eventually you're going to add up to infinity. Your number just gets bigger and bigger and bigger and bigger and bigger. If you subtract 5 every time and do that forever, you're eventually going to add up to negative infinity. And it's really boring to have those be the only two answers you can get. Positive infinity if it's adding numbers, negative infinity if it's subtracting numbers, you're done, that's boring. So when we deal with arithmetic series, we only look at finite arithmetic series because then we have specific answers we can get that are not just, oh, it gets really big, oh, it gets really big, negative. Okay? Does that make sense why we're looking at those specifically? Okay, so the formula that we use for this is S sub n. So this is like our partial sum formula. So we're saying we want to find the first 5 terms, or we want to find the first 28 terms, or the first 17 terms, or whatever. And it is n divided by 2 of the first term plus the last term. That's what that notation means, the first term plus the last term. So if you're finding the sum of 28 terms, then you would do 28 divided by 2. You would find the first term and write it there. Find the 28th term and write it there. And then you'd plug in your formula to the calculator and see what you get. Okay? All right, so we're going to go ahead and go through some examples. The instructions say find the sum of each series. And just like we did yesterday, I'm going to phrase it a few different ways so that we can be comfortable with it no matter how they ask. So the first way we're going to phrase it is we're going to say they want the 28th partial sum of, and the pattern is 27 plus 14 plus 1 plus ... So to find the partial sum, we need 3 pieces of information. We need to know how many terms we're trying to find. So how many terms do we need for the 28th partial sum? 28, so we know n is 28. We need to know what the first term is. What's the first term? 27. And we need to know what the last term is, which in this case is the 28th term. Do we know the 28th term? No. So what could we do to find the 28th term? We could follow the pattern out to the 28th term.
That's what I tried to do, but then I lost count.
Yeah, well, you could do that, but you lose count, right? Or we could write a formula for it, for the sequence. Pretend these have commas. We could write a formula for the sequence, figure out the 28th term is, and then use that. Okay? So if I was to write this sequence out, I would say I've got my first term, which is 27, plus n minus 1 times, what's the d value here? Negative 13. So there's my formula for finding any specific term of the sequence. And now if I want the 28th term, I can just plug in 28. So go ahead and grab your calculator, plug in 28, tell me what you get. Yeah. Negative 324. Okay, so we have the number of terms that we're looking at. We have the first term. We have the last term. So now we can write the 28th partial sum is the number of terms that we have divided by 2 times the first term plus the last term. And you can literally type it in just like that. So go ahead and type that in. Let's see what we get. It's a 4-digit number for those of you who are not sure if you got it right or not. Starts with a 6. Oh no, that's the next problem. It starts with a 4. It's a negative. Sorry, it's a negative number. It starts with a 4. Yeah, 4,158. Sorry, I was looking at the next problem. All right. Did we get that okay? Okay. All right, let's try a second example. So for the second example, I'm going to use the sigma notation. How are we feeling about sigma notation? It's okay? It's not okay?
It's okay.
Okay, so here's the problem. How many terms are we trying to find here? 19. We want 19 terms worth. We're starting on the first term, so that's good. Can you tell based on the way they wrote the equation what the first term is? It's negative 19, right? This is written just like the formulas are, so the first term is negative 19. If you weren't sure about that, how could you have found the first term? You could plug in 1. Plugging in 1 would have given you the first term, and it would have given you negative 19. What else do we need to plug into our formula? We have the first term. We actually don't need D for the series formula. We need the 19th term. So we have the number of terms, we need the first term, we need the last term, which for this problem is the 19th term. So we're going to do negative 19 plus 19 minus 1 times 42. So what do we get for the 19th term? 737. All right, so the sum of the first 19 terms is going to be 19 divided by 2 times negative 19 plus 737. All right, so go ahead and type that in. This is the one that starts with a 6. 6,821. Perfect. All right. Here's the third example I have for you. We're going to start with the 6th term this time, and we're going to go to the 28th term. And the formula is 5n minus 17. Okay. So how many terms are we working with from the 6th to the 28th? 22. And most people would say that, right? You did 28 minus 6. But I want you to look up to this one. This one was 19 terms. And if you do 19 minus 1, you get 18. So it's 23. So you subtract the numbers and add 1. That's the trick to finding out how many numbers are there. Because we're not saying how many, when you subtract numbers, you're saying how many numbers are in between. I don't want to know how many numbers are in between. I want to count the actual numbers themselves. So that's why I add 1 to it. So if you get confused, just look back at one that actually starts at 1. From 1 to 19, we know there's 19 terms. But we know that 19 minus 1 is not 19. So we're going to do 28 minus 6, and we're just going to plus 1. Always, always, always just plus 1. Okay? So that means we have 23 terms. We want to do the first term, which is actually the 6th term. How do I find the 6th term? I plug in 6, right? So 5 times 6 minus 17 is 13. Then I need the last term, which is the 28th term. I have 5 times 28 minus 17 is 123. And so what people typically do on this is they think of the problem a little bit differently. They say, okay, this is the 6th term, but I'm going to call it the first term. They say this is the 28th term, but I'm going to call it the 23rd term. Does that make sense? So I'm just renaming my terms. And then they say, okay, the first 23 terms from this one to this one is 23 divided by 2 times the first term, also known as the 6th term, right? Plus the last term, also known as the 28th term. All right, and what do we get? Okay. All right, was that one reasonably okay, even though they started somewhere other than the first term? Did it still make sense once we did it? So the tricky part about this one is just figuring out how many terms you have, but other than that, you can still say the first term I have, the last term I have. You can still do it that way. Okay? All right, I've got one more tricky one to show you, and then we'll be practicing using the book problems. So here they're going to give us a series to work with, -5, +2, +9, plus the pattern continues here. And then the final number you're going to work with is 317. All right, so we need to know the number of terms that we have. And based on how they wrote the problem, that's like the only thing we don't know, right? I do know, however, that the first term is -5. I know that. And I know that the last term, whatever term number it happens to be, I know that the last term is 317. But I somehow have to figure out what the n is. I have to figure out how many numbers, how many terms I do have. So this is a problem where we don't have enough information, so we're going to have to go back and we're going to have to look at the sequence itself. Okay? So I'm going to write the formula for the sequence itself, which is the first term, right? What's the first term? Plus n minus 1 times the d value, which is 7. Okay? And now we're going to say whatever n value they plugged in, they got 317 as a result. Does that make sense? Whatever n value they plugged in, they got 317 as the result for that. So I'm going to say 317 equals -5 plus n minus 1 times 7, and that's how I'm going to be able to figure out what my last term number should have been. That's going to tell me how many terms I have in my series. So I could add 5 to the other side. That gives me 322 equals 7 times n minus 1. And then what could I do? You could distribute, but you could also do something else that would save you a step. You could divide by 7. If you distribute it, you're just making it more complicated before you start to move stuff over. If you divide the 7 over right now, then you're going to be simplifying as you go. So 322 divided by 7, so 46 equals n minus 1. Add the 1 over, and so that means that 317 was the 47th term. So the first term is -5, the 47th term is 317, and so how many terms are we adding together? (47), right? The first to the 47th is 47, right? So we're going to say S sub 47 is 47 divided by 2 times the first term plus the last term. And what do we get? All right. How do we feel about that? So what you should be writing as far as a cheat sheet goes at this point, for today, we definitely need to have 3 formulas written on a cheat sheet. We need to have the explicit formula, the recursive formula. Those are both in reference to sequences. And then we need to have this sum formula. 3 formulas for today. Okay? All right, any questions on that? Okay, so at this point, we're trying to finish that book assignment or get as many problems done as we can. Okay?